And now we introduce the next part of what we have going on here. Simultaneous solutions involved with graphing lines. And we're going to kind of fuse or combine our literal equation skills with our graphing skills. And I say our graphing skills. We should bear in mind that this is something that was heavily taught in high school. So I'm going to expect that you know things like how to graph a point. I'm going to review with you y equals mx plus b for slope and y-intercept. So I think you should have those fundamentals and basics down pat. And then we'll build on it from there. But a quick review of fundamentals and basics. Slope and y-intercept. The general equation of a line is y equals mx plus b. You know, in different regions of the world, people are named differently. I can think of a biblical character, Joseph from Arimathea, and they would say your first name, Joseph, and then the town you were from, or even that transferred into, like, I studied Spanish in high school, and I even as a teacher, I would get certain students in my class, like a name I might get might be Juan de los Castillos, and de los means of the or from the, and that would be Juan or John from the Castillos, a particular region in Spain. So there's a structure to our names, all right? My particular name is Robert. I hate that name. My friends call me Bob, but Robert Lindquist Jr. And the junior signifies, okay, well, that's part of my name because my dad also had the same name, same last name, Lindquist, and the first name is Robert, whereas my sons are Robert III. My wife picked it. I didn't want any part of it. And then also Jimmy. So you would look up Lindquist, my children, and then say, well, which one are we talking about, Robert or Jimmy? When we look at the equation of a line, y equals mx plus b, the stuff in black here, the y, the equals, the x, and it could be plus or minus here, that never changes. Kind of like Delos Castillos or Lindquist. But what does change is the other parts of the equation. And whatever number's in front of the x, the m there, that's the slope. And the y-intercept is the number at the end when you get it into y equals form. So this shows you, you know, we were working on those literal equations, and this shows you why we worked on those. Because when we do a standard equation for a linear equation, y equals mx plus b, we want it to say y equals. It's very important that it does that. Now, just a side note here, I was the kind of student in school, I would sit there and say, why in the world are they using an m for slope, right? M isn't, like, slope starts with an S. Why are they using an M? And one of the things I've come to realize is that the slope is how you move. So M for movement is a good thing, and the y-intercept is where you begin, hence the letter B for y-intercept. Graphically speaking, the B is where you begin. It's called the y-intercept, so it's where you touch the y-axis. Think about intercepting a football. The line is being passed from down on the left here by the quarterback to the receiver out here at the top of the graph. And if it intercepts the y-axis kind of grabs it as it goes there. So the y-intercept is where it touches the y-axis, and then how you move after that. So like this one touches at 1, so B would be 1, and then you move up 2 over 1, up 2 over 1, up 2 over 1 to get back on the graph. So we would say that this slope is 2 over 1. Okay? All right. Don't worry about the graphing end of it now. It's just kind of relating the two together. We're going to come back to the graphing in a bit. But here are 3 equations, and what I want you to do is focus on the general format of y equals mx plus b, and for each of these equations, tell me what the slope is and what the y-intercept is. Go ahead. Okay, so in the first one, the slope is always found directly in front of the x. Once it says y equals, it must say y equals first. So the slope is 2 and the y-intercept is 7. That means you would begin at 7, b, y-intercept b, begin at 7, and then move up 2 over 1. Second one, what's the slope? What's the y-intercept? So the slope would be whatever's in front of the x, which is 3/5, and the y-intercept would be -2, whatever number's at the end here. Remember, I did say that that could be a plus or minus sign at the end. I would begin at -2. I would touch the graph at -2 on the y-axis, not the x-axis. Some students make that mistake, on the y-axis. And then I would move up 3 over 5, up 3 over 5. For this last one, what's the slope? What's the y-intercept? And just a little bit of a hint here, when it comes to what the slope is, you're going to need to remember what's in front of an x if we don't write anything. Okay, so in this case, the slope is -1 because there's really a 1 in front of that x. We just don't bother to write it. And of course, the negative sign tells you it's a -1. And the y-intercept is 3. So if I were to graph it, I would begin at 3. And then all the negative slope means is go down. So I'll go down 1 over 1, down 1 over 1. In the first one up here where the slope was 2, it was up 2 over 1. If I don't write a denominator, like I did in the middle, we assume the denominator is 1. So we just go over 1. All right, so that's really a review of stuff that I'm sure you've done when you were younger. Okay, now let's find some M's and some B's. Okay, let's have you work on numbers 1 through 5, and unfortunately, I already have the answer to number 6 on here, so I'm kind of spoiling the surprise there. Let's work on numbers 1 through 5, and then we'll go through number 6 together with the surprise spoiled. But that's all right. So do numbers 1 through 5. Stopping and starting, of course. Okay, so on number 1, the slope is 7, the y-intercept is -11. All right, because 7's in front of the x, -11's at the end. Next, for number 2, slope is 1/4. Remember, there's really a 1 in front of the x, so the fraction is 1/4 here. The y-intercept is 1. Next, there's nothing at the end. What number represents nothing? 0. So the slope is -3, the y-intercept is 0. I would begin at 0 and move down 3 over 1. Number 4, where would you begin? What is the slope? How would you move? Well, I would begin at 3, and I would move down because it's -2 over 3. So down 2 over 3, down 2 over 3. Number 5, y equals 4x minus 6. The slope is 4. The y-intercept is -6. So I would begin at -6 on the y-axis. That's why we call it the y-intercept. And I would move up 4 over 1, up 4 over 1. Now, what about number 6 and this surprise that's been spoiled here? Well, if you look at numbers 1 through 5, every one of them says y equals, y equals, y equals, y equals, and y equals. Number 6 does not. Number 6 says 2y equals. And here's where we come back to our training with literal equations. We want it to say y equals, like numbers 1 through 5. So I have to divide everything by 2, which I do, and that gives me 4 divided by 2. This is why we worked on that skill where we broke them apart. 4 divided by 2 is 2, and -6 divided by 2 is -3. So that gives me the equation y equals 2x minus 3, and the slope is 2, because that's what's in front of the x, and the y-intercept is -3. So many students, the first time they see a question like number 6, will believe, just like number 5, that the slope was 4 and the y-intercept was -6. But how could that be when the equation for number 5 is y equals, and the equation for number 6 is 2y equals? So we always have to convert to a y equals form. So very, very, very important. Now, actually graphing lines, what we're going to do here, I'm going to graph the second line that we came up with and talk about exactly what the graph of a line is. The graphing of a line is showing you all the points that work in a particular equation. So this is how we apply M and B, and then I'll show you that all those points will check. So we said that we begin at the B. So the y-intercept is 1. So the first thing I do is touch at 1 on the y-axis. There it is. Now the slope is given an M because it tells you how to move. In this case, it's 1/4, and it's always rise over run or change in y over change in x. So I'm going to go up 1 over 4, up 1 over 4. So there's up 1 over 4, and then I go up 1 over 4 again. And now I just do connect the dot, and there is my line graphed. So I begin at the y-axis, and I move according to what the slope tells me, the M for slope, up 1 over 4, up 1 over 4. Now, this blue line is a picture of all of the points that we'll check in this particular equation. Like, let's just check a couple of them real quick. Let's check 0, 1. If I plug in a 0 for x and a 1 for y, it checks, right? 1 equals 1. Let's plug in 4, 2. If I plug in a 4 for x, 4 divided by 4 is 1. 1 plus 1 is 2. So that works. In fact, every single point on that blue line is a picture of, a representation of, every pair of coordinates that check in this equation. And if the coordinates do not check or work or solve the equation, then it's not part of the line. It's one of those areas that doesn't have a line on it, or one of the coordinates that doesn't have a line on it. So, summarizing what we've learned with this, we threw a lot at you. It must say y equals. You always begin at whatever the y-intercept is, the b at the end, and then you move according to whatever the slope, the m for slope tells you mx plus b. And then you connect the dot, and what you're getting is a picture of all of the points that check or satisfy or work in the given equation. So here's one for you to do now. 3y equals negative 9x plus 6. I want you to graph it. If you want, you can graph it on a separate paper. You can print graph paper right off of the internet. Just Google coordinate graph paper and then print it, and you'll have all the graph paper that you need. Keep in mind as you're doing this, I don't care what 3y equals. I want it to be in y equals mx plus b form. So, like a literal equation, you need to solve for y. Go ahead. Okay, so I assume you did stop and start and you actually solved. So the first thing I do is divide everything by 3. That gives me y equals negative 3x plus 2, which tells me that the slope is negative 3 and the y-intercept is 2. So I begin at 2. This is going to be my green line. There's beginning at 2. Now, the slope is negative 3. It doesn't give you a denominator, so that means over 1. The negative means move down. We always go left to right. So I'm going to move down 3 over 1, left to right. Look, down 3 over 1. Now I'm going to repeat it, down 3 over 1 again. And just one more time, down 3 over 1. There it is right there. If I wanted to put the dot there, or the point, mark the point. And here are all the coordinates that check in the green equation. 3y equals negative 9x plus 6. So, we can fit more than one graph on one of these. So let's have you try y equals x minus 2. And what's really cool here is that it's already in y equals mx plus b form, so this should be pretty quick and easy. So the slope is 1, because that's what number's in front of the x, even though we don't bother to write it. The y-intercept is negative 2. So this is going to be the blue line. I begin at negative 2, and I go up 1 over 1, up 1 over 1, and I think I do one more point here. And up 1 over 1 is the same thing as up 2 over 2 or up 10 over 10. So this time I did up 3 over 3, which is the same as up 1 over 1. I just did that to spread the line out a little bit more. There are the points connected, and there's something very important going on here. I didn't give this a fancy title, but what is often done is you are told to solve the following simultaneous system of equations, which means you're given the first line, 3y equals negative 9x plus 6, second line, y equals x minus 2. And you are expected to do exactly what we just did. Graph the first line, graph the second line, and find the point, the coordinates of the point where they both check. Now let's go back to what I said before. I said that the blue line is a picture of all of the points that check, work, or satisfy the blue equation. The green line is a picture of all the points that check, work in, check in, work in, solve in, satisfy the green equation. This one point right here, this magical point where they cross each other, that's the only point that works in both equations. So that's the simultaneous, works in both equations at the same time, simultaneous equations. And that coordinate is 1, negative 1. If you wanted to, you could check that coordinate in both equations. Whenever you check this, it's in both answers in both equations. But at this point, I'd rather really focus on how to do the questions. So once again, make them both in y equals mx plus b form, graph them one at a time, and mark the point where they intersect. That is your solution. The solution to this problem is 1 comma -1. That means x is 1, y is -1. Okay, so here is the first line to graph on a new set of problems. We're going to do this one and one more after this. Solve simultaneously. We're going to give you 2 equations, graph them both. Okay, so here's my first equation. This is not in y equals form. This does not say y equals. It says y minus 4 equals. So as we learned with literal equations, I have to get y all by itself. So I add 4 to both sides. And that gives me the line y equals -2x plus 4. What's the slope? What's the y-intercept? Slope is -2, y-intercept is 4. So this is going to be the green line. I begin at 4, and I go down 2 over 1, down 2 over 1. Look at, there it is. Right, down 2 over 1, down 2 over 1. Why do we go over 1? Because there's no denominator in -2. And like 7 is really 7 over 1, or 11 is really 11 over 1. -2 is really -2 over 1. So that's why I slide over 1 when I do that movement. And now I connect the dot. So there's a picture of all the points that work, satisfy, or check in that first equation. Here's my second equation. Go ahead, graph that guy. Okay, so we're going to divide everything by 3. And that gives me a slope of 1/3, right? There's a 1 in front of that x. And a y-intercept of -3. So I be or begin at -3. Here's my blue line. And then I'm going to go up 1 over 3. And look what I did here. I went up 1 and over 3. And I just keep going to finish off the problem. There's my connected dot. And there's my magic point right there. The only point that's both green and blue. It satisfies both equations. I mark that as my solution. That's the point 3, -2. Okay? So there is the correct simultaneous solution. Let's do one more simultaneous solution problem. Here's the first line to graph. Make it sure it says y equals at the end, right? So you got to do something about that -6 and something about that 2. Okay, so first I add 6 to both sides. 2y equals -2x plus 6. Then I divide by 2. And I get y equals -1x plus 3. So the slope is -1. The y-intercept is 3. And again, just to mention one of the things I love so much about math. If I move down 1 and over 1, that's the same thing as moving down 2 and over 2. And if I reduce -2 over 2, I get -1. So whether I want to look at this from an arithmetic point of view with how to reduce a fraction, or if I want to look at it as graphing, it works out the same either way. And that consistency, that reasoning and understanding, that's the power of mathematics. That's what makes mathematics great. Not how to line up the decimals when you add decimals, or well, why you get a common denominator is pretty cool, but that you have to get a common denominator, or any other thing that you come out with in math, when you express math as a bunch of stupid rules, that's not good. But when you understand it as this is very good. Okay, so I begin at 3, green line here. I'm going to move down 1 over 1. But you know what? If I move down 1 over 1, I'm really not going to get much of a line here. So I chose to go down 2 over 2. Let me do that again. Another down 2 over 2. And I connect the dot. So there's my green line drawn, and remember that's a picture of all the points that check or satisfy the equation 2y minus 6 equals -2x. Now, the next one is y equals 2x minus 3. Oh, look, I was nice to you, gave it to you in y equals mx plus b form. Go ahead. Okay, so the slope is going to be 2. The y-intercept will be -3. So I begin the blue line at -3, and then I go up 2 over 1, up 2 over 1. Oh, always comforting when it lands on a perfect point. Up 2 over 1, connect the dot. And there is my solution. It's right where the green and blue points lay on top of each other. That's the point 2, comma 1. And if you check it, look, let's plug it in real quick. Let's plug in a 1 for y. 2 times 1 is 2, minus 6 is negative 4. Plug in a 2 for x. Negative 2 times 2 is negative 4. So both sides are negative 4. Let's try down here. Let the y be 1 and the x be 2. 2 times 2 is 4, minus 3 is 1. So 1 equals 1. So it checks in both. Okay, the happy recap for today's new material. First, get the linear equation into y equals mx plus b form. Second, identify the slope and the y-intercept. Remember, slope is m, y-intercept is b. Why do we use an m for slope? Why do we use a b for y-intercept? M is how you move, and the slope is how the point moves. And the b is where you begin, which is what the y-intercept does. Last but not least, if you're doing simultaneous equations, just do each line individually. Graph them both, find that point of intersection. Okay, so listen, I think you figured out how I teach. The next lesson we have, we're going to do a number more of these simultaneous solutions. Today was like the beginning of learning it. We will do more of them. What do we have? We'll do some on Tuesday. We'll do some during our pretest we'll do some on Monday. We'll do some on our pretest on Wednesday. You'll get 3 opportunities to learn these simultaneous solutions before you're expected to take them on your test. Okay, have a great one.